So now let us go through example number 2 under application of a system of linear equations. So example number 2, a salesman has the following record of sales during 3 weeks for the 3 items X, Y and Z, which have different rates of commission. So our information or data is represented or given in the form of table. So a salesman is having a record of sales for 3 items X, Y and Z. These are the items sold X, Y, Z, and it is for the period of 3 weeks. First week, second week and third week. And in the first week, what is the total rate of commission? Total amount of commission is given in Ultram, and similarly for second, third week, all the rate of commission is given. So, and our question is, find out the rates of commission on the items X, Y, Z using matrix inverse method and determinant method. So you have 2 sub questions. You have to solve this problem using matrix method, and second you have to solve using the determinant method. I mentioned before, you have to remember the steps. So whenever you have this application based problem, first step is to represent this information in the question in the form of system of linear equations. Get in the form of system of linear equations, transform into matrix and use the appropriate method to solve the problem, either matrix method or determinant method. So now what you can do is, if you let X, I am using the small letters X, Y and Z, be the rates of commission in Ultram for the items. Our items are given in terms of X, Y and Z respectively. You can use it for 3 items. So rate of commission, X is for big X, Y is for big Y and Z for this big Z. So if you let this X, Y, Z be the rates of commission for the items, then you can obtain the system of linear equations. So let us go through the solution. First is using the matrix inverse method, how to solve that problem using the matrix method. So first you have to let the variables X, Y and Z be the rates of commission for the items. We have 3 items X, Y and Z, right, respectively. Then since our information is clearly given in the table in the problem, in the question, you can directly get the system of linear equation. For example, from the first row of the table, you can obtain the equation number 1. For example, 40x, okay, 40x plus 30y plus 20z is equals to 270. What does it mean? The 70 is the rate of commission for the item X. No, 40 is the rate of commission for the X, and 30 for Y and 20 for Z. If you add up, the total amount of commission should come up to 270. And second equation similarly is obtained using the information given in the table directly from the quotient. You have 50x plus 50y plus 40z is equals to 450. And third equation is 60x plus 30y plus 10z equals to 260. This is our third equations. So this equation are obtained directly from the given table in the quotient. Okay. So next step is to how to transform this system of linear equation into matrix. So as you know, the coefficient of this system of linear equations form a matrix A, which is 40, 30, 20, 50, 50, 40, 60, 30, 10. And our matrix X is the variable matrix, which is X, Y, Z, and our constant matrix B is obtained from the constants of the linear equations. So once you obtain in the form of matrix, you can directly go to the solution. Our next step is to find the determinant of the coefficient matrix A. So if you calculate the determinant of the coefficient matrix A, we obtained as negative 1000. Since the determinant of matrix A is equals to negative 60, negative 1000, which is not equal to 0, we can say that the inverse of the matrix exists and the solution for the system of linear equation can be obtained by using this formula where x is equals to A inverse B. So next is, based on this formula, you have to obtain the value of A inverse. The formula to find the A inverse is 1 by determinant of A times adjoint of the matrix A. Okay, so A inverse is obtained by using the formula 1 by determinant A times the adjoint of matrix A. So how do you find the adjoint of matrix A? Determinant we have already calculated as negative 1000. So how do you find the adjoint of matrix A? The adjoint of the matrix A is obtained by taking the transpose of the cofactor matrix. So adjoint of the matrix A is given by the transpose of the cofactor matrix. How do you find the cofactor of the matrix? We have already gone through in the earlier lectures. So next is that how do you obtain the cofactor of the coefficient matrix A? So as we have gone through how to compute the cofactor matrix in the earlier lectures, so I have directly computed the cofactor matrix here. So next, once you get the cofactor matrix, you can take the transpose of this, means swap the rows and columns to get the adjoint matrix A here. So once you get the adjoint matrix A, our final solution for this is obtained by using the formula 1 over determinant A times adjoint A times B. So 1 over determinant of A. Determinant of A is minus 1000. What's adjoint A? Adjoint A is here, this matrix. And what is matrix B? Matrix B is a constant matrix B. So if you multiply these matrices, then you will obtain the final answer. So our final answer is 2, 3 and 5. Therefore, we can say that the x is equals to 2, y is equals to 3 and z is equals to 5. So now we are trying to solve the same problem, that's example number 2, using the determinant method or Cramer's rule. As we have gone through before, in order to find the solution using determinant method, you have to find the value of d, that is the determinant of our coefficient matrix A, so which is equals to 1000. So since the determinant of this coefficient matrix A is determinant of the coefficient matrix A is not equals to 0, we can say that the unique solution exists. And the solutions are obtained by the x equals to d1 by d, y is equals to d2 by d, and z is equals to d3 by d in this example. So next, how do you find the solution for x? X is obtained by using the formula d1 by d. So that means you have to find the value of d. So d1, to find the value of d1, that is the determinant, you have to find the determinant of our coefficient matrix A, but you have to replace the first column of the coefficient matrix A by the constant matrix B. So if you put it here, then you get the value of d1, which is equals to minus 2000. So therefore, our value of x is equals to d1 by d minus 2000 divided by minus 1000, which is equals to 2. So next is how do you find the value of y? To find the value of y, the formula is d2 divided by d. So how to find the value of d2 is the determinant of the coefficient matrix after replacing the second column of the coefficient matrix A by the constant matrix B. So when you do that, you get the value of d2 as negative 3000. So by substituting the values of d2 and d in the formula, we get minus 3000 divided by negative 1000, which is equals to 3. Therefore, our value of y is equals to 3. Next, you have to find the value of z. Z is obtained by using the formula d3 divided by d. How do you find the value of d3? It is the determinant of the coefficient matrix after replacing the last column or the third column of the coefficient matrix A by the constant matrix B. So therefore, we obtained the value of d3 negative 5000. So what's the value of z? You can plug in the values. d3 is equal to negative 5000 divided by negative 1000, which is equals to 5. Therefore, our final solution is x is equals to 2, y is equals to 3, and z is equals to 5.